My name's Travis. If you haven't met me yet, I'm a senior engineer with Pointwise. So to start off, I want to discuss what a scriptable problem is. But before I do that, how many of you use glyph scripting? Just by a raise of hands. 2. How many of you? 3. Okay. How many of you would like to use glyph scripting in some part of your work? You should all raise your hand. Okay. Most of you. Okay. So my job here today is to not only give you a brief introduction, some best practices, if we have time, close up with an example, but also ultimately convince you why you might want to invest in writing a script for some of your applications. So a couple of things that you can use glyph scripting for are noted here on the screen. Everything is in your notes, so some of these I may go through pretty quick just for the sake of time, but rotating an image, applying a user-defined connector distribution function rather than the 4 or 5 that we offer in Pointwise. Maybe you have your own. Automatically generating grids, automatically generating geometry, changing topology, like for example in the last bullet, transforming an H topology. Say you've meshed a pipe using an H topology or a similar topology to what Eric chose to use on the tip of that blade, and you want to convert it to an OH style topology. There are scripts to do that as well, and then propagate that change throughout the rest of your mesh. Those are just some examples. You have the ability to write your scripts with a GUI, so you can make very nice looking utilities that you can launch independent of Pointwise or from within Pointwise itself. This one that's most prominent is a turbine siting application. It loads in a terrain file. It actually shows you in the script GUI itself. You enter in your parameters and it renders what the grid would look like within the script before you actually go ahead and create the mesh. There's a shape creation utility which ultimately will be baked into Pointwise version 18, which you'll hear about a little bit later. Some utilities for creating airfoil geometries and grids. And a lot of this stuff is available on our GitHub page, and there's a link to that in your notes. So those are some things that you can use scripting for. So what are the different types of grids or glyph scripts that you can write and the benefits? Well, ultimately, scripting really allows you to customize Pointwise to fit your needs, and sometimes it allows you to do things that Pointwise wasn't necessarily intended to do. And Eric has talked just briefly about this. When you write a glyph script or when you're in Pointwise and you're doing something, it's a noun-verb paradigm. You pick an object, you apply an action, and usually that's the end of it. Well, in glyph, you can apply many actions, and in the end, sometimes you can write your own features to do things that Pointwise, again, wasn't intended to do. I like to call that hacking Pointwise because it's ultimately really interesting to see the types of things that you can do with different entities in Pointwise. Now, there are 2 types of glyph scripts that you can create in Pointwise. The first is a utility script or a macro. So you're encapsulating something that's very repetitive, maybe very tedious. Probably my favorite example of this is from my meshing experience when I'm doing solid modeling and I'm in the quilting stage. So I've created my model and I'm trying to create as few quilts as possible, so that when I mesh the model, I get as few domains as possible that represent something physical. When you assemble quilts and you pick 2 quilts that are adjacent to one another, you have to move your mouse like 3 inches to the toolbar to click the button to assemble those 2 quilts together, right? That's a long way. So I wrote a utility script that does that for me. So when I start clicking quilts, I can just use Control-E, which is execute the last script, so I don't have to move my mouse to the toolbar to click a button. Do that. And those are the types of things you can do with a utility script. They're very quick to write, and they encapsulate very tedious tasks. To me, that was tedious, moving my mouse 3 inches. The other type of script you can create is a meshing script or a template. And this allows you to automate the entire meshing process start to finish, or most of it. It's great for optimization. A good example is, automating the meshing for an airfoil or a turbine passage like what you saw earlier today. But in the end, it's not always practical. You can't expect to mesh the world, right, from automotive applications to turbine machinery. You pick a problem type, you boil it down to what it is, and you script it. And that allows you to get that thing done very quickly. But expanding it and encapsulating many different things isn't always practical. So before you start writing a glyph script, and before we even talk about this, probably before you define your scope, the prerequisite is you need to know how to use Pointwise. I mean, when you write a script, you're calling commands from Pointwise, and in Pointwise, everything is scriptable. So it's really important that you understand how to use the software, you understand the commands that you're going to be using, and at a minimum, you know how to mesh what it is you want to automate. So that way you know what commands you're going to use and you know how they are being used. Okay? It's very difficult to jump into the glyph docs and try to find the commands that you want if you don't know what you want. So the prerequisite for scripting is knowing how to use the software, particularly for the problem that you want to automate. Beyond that, the next step is defining the overall scope of your problem. What is it you want to accomplish? Kind of constrain it a little bit. Divide and conquer that script, so write procedures, write functions to encapsulate repetitive tasks within that script itself. That's good for debugging. It's good for repeatability, so you can pass this along to other people and they can use pieces of the script as well. And then ultimately, in the end, keep in mind that big picture. You can add complexity to your script, but always keep in mind that end goal and don't let it get too unwieldy and try to encapsulate so many different things. Okay, so do we have any questions so far? Okay. So the basics, and we're talking real basic here. Tcl 101. Tcl stands for Tool Command Language. It's a scripting language that processes all its data as strings. This is what Glyph is built on. Very basic commands are terminated by a new line or a semicolon, and commands can be continued using a backslash character to break. Just here are some examples. So in the first example, we're setting the variable a to 5. We're using a semicolon to move on, set b to 12, and then blank space to terminate that line. And then we can also, like I said before, use the backslash to, if we have like a really long command that we want to break onto a new line, we can use the backslash character to do that. Okay. Very, very basic stuff. Tcl has a great website, great documentation. You can see how to use, your if statements, for loops, things like that. It's all on there. That's just a brief intro to Tcl. So what is Glyph? Well, Glyph is our scripting language built on Tcl 8.5 with Pointwise commands added to it. Okay? Pointwise, or Glyph, is procedural and it's object-oriented just like Pointwise, and most importantly, it allows you to access every single one of Pointwise's features. What that basically means is anything you do in the GUI has a scripting command. So that's extremely powerful. That means that if you can do it in the GUI, you can do it through a script. Why do you need it? We've already talked a little bit about this, and so has Eric. Allows you to kind of prevent repetitive things from going on. You can use a script to reduce the time for repetitive tasks. Some basics, okay? Glyph is actually the means by which the GUI and the core of Pointwise communicate. So what that means is every time, again, you click on a command in Pointwise, it's executing a Glyph command. That means Glyph is really robust because every time you're using the software, you're exercising Glyph. In fact, you can take all of those commands and send them to a file through journaling, or you can send them to the message window and you can see exactly which commands you're using when you click a button in the toolbar. Or if you wanted to see, for example, the commands that are being used when you create a connector, you're just curious, you can turn on journaling, create a connector, and see exactly what Glyph commands are being used. And then you can look them up in the documentation as well. Glyph mirrors the GUI operations. I mentioned this before, this noun-verb style. And what that means is in the GUI, when you pick a connector, you then go pick an action, a verb. So the connector is the noun and then the verb. So you pick an object and you apply some action to it. And Glyph is the same way. So you'll notice that we pick the connector, con, and we're setting the dimension to 11. So there's this mirror. They're exactly the same. They work the same way. Okay. So it's a good idea to understand objects in Glyph. An object is basically an entity that you can create and use in Pointwise. Database entity, connector, domain, block, etc. Objects are created by calling the create action on the object's type, and we'll talk about types in a minute, But just to give you an example, here we're creating a variable con that's going to hold a connector object, and we're using the pw::connector type and calling the create action to create an instance of that type, or a connector object, which then we're going to set the name to wingtip. So again, we have the object con, the action set name, and then what we want to change its name to, which is wingtip. So what's a type? Well, a type is used to group together various actions. Okay, they could be defaults, attributes, other actions that define that noun or that entity. They're usually of the form pw::. There's some that are of the form pwu::, and they're followed by the type name, and the first letter is always capitalized. And the object is an instance of that type. So for example, in the bottom here, you can see pw::connector. Connector is the type. Any instances of that type would be considered a connector object. Okay? So some types are interfaces to the objects that you work with in Pointwise, like connector and curve, but other types just group together commands, like application, which will hold all the I/O commands, display, your display manipulation commands, etc. Script execution. This slide basically just outlines the various ways that you can run scripts in batch mode. Okay? Using the GUI, you're just going to use the execute command from the script menu. So I'm not going to spend any time on this. It's in your notes, so you can refer back to this depending on the system that you're using. Script execution and journaling. Talked about this a little bit. In the script command, there's an execute button, and that's what's going to allow you to run your script within Pointwise. You can journal scripts within Pointwise. There's a begin journaling, end journaling, and append to journal commands within that script menu. In the right-click menu in the message window, there's also the option to enable journaling, so you can see the commands printed to your message window. That's probably my favorite feature, because if I forget a command for creating an object, I can go ahead and, since I know how to use Pointwise, I can do it in the GUI and print everything to the message window and see the commands that are being used. And then I can take those commands and look for them in the documentation to get more information about the various things that they accept. Okay. I do want to mention something about journaling. Journaling is fantastic for just what I described. Learning the commands, if you're unsure of what a command is to do something, or if you want to accelerate writing a script, it's great for that, in that you can journal something, you can take that code and paste it into your script and clean it up. If you've ever journaled anything from Pointwise, how many people have journaled something from Pointwise before? Okay, a couple people. If you've noticed, it's really verbose. There's a lot of stuff that gets journaled along with the commands that you actually need. Temp variables are created, a lot of stuff that you don't really need. Not to mention, Pointwise isn't the most efficient when it's journaling. It doesn't know that when you create 4 connectors that you would rather have a procedure to create connectors and just feed it arguments, right? In your script, you would probably have a single procedure to create connectors and you'd call it 4 times. But if you journal something, you're going to get 4 instances of that code to create each connector. So it's not always the most efficient. If you take that journaled code and you save it, and 5 years down the line it doesn't work, there's probably something that happened. We maybe renamed an object or something like that. We added a new attribute or something that's required by that object. So it's not recommended to journal your code and use that for production work. Take that code, use it as a way to learn the commands that you need, and then write something from scratch. Okay? That's my recommendation. Here's where you can find more information about the Glyph reference manual. Now we're going to kind of walk through it because I think this is a valuable piece of reference for Glyph. So once you're in the reference manual, you can look at types, or you can look at things by type. So you can go through here and go alphabetically and try to find the type that you're interested in. So you want to operate on blocks. You can find the PW block type, click on it and see all the actions for that type. Similarly, you can look at functions as well. So you can see all the different functions. You can even see what types they're associated with, and you can get more information about them that way. The way I like to use it is, since again I know what I'm going to be scripting, and I generally know what types I'm going to be working with, I can go to that type, which in object-oriented terminology is more like a class. So here I know I'm going to be working with structured domains. So I go to the domain structured class. I can see all the inheritance, so I can get more actions to apply. I can see the class methods, including the static create command where I can create instances of that object. I can see the defaults, which I can set, which the objects will inherit once they're created. And then I can see the methods that can be applied to the instance of that class. So any structured domains I create, I can use these methods to change their attributes. Okay? So this is another way that you can navigate these docs. And here are some more references. I'm not going to go into this. Maybe the only thing I'll mention is our GitHub page. At the bottom we have quite a few scripts up there that you can use as reference. So you can go through them and see kind of our coding practices and the commands that we're using, as well as just use them for your own work. There's a lot of really great cases up there, utility type scripts. Okay, so I'm going to talk a little bit about best practices for Glyph. So some tips for pain-free scripting. The first thing is Tcl variables. They're going to be strings or arrays of strings, and they're case sensitive. We've already seen how to assign a variable, so you use the set command. So in this case we're setting the variable condim to the value 10, so set condim to 10, and then we can recall that variable using the $sign. So we can say set condim copy to $condim to also set the value of condim copy to 10. Okay. Now, something about variable names, they are case sensitive. Notice how we use camel case notation, okay, and the first letter is lowercase. This is how we can differentiate between variables and, say, procedures, which we'll talk about later. You don't have to do it this way, but if you look at all of our scripts online, this is the practice that we use. And the scripting tip at the bottom is important. Please use meaningful variable names. 6 months or a year or 2 years down the line when you look at your script, you'll probably want to know what those variables are, but so will I when you send me the script and say, hey, what's going on with this variable? I'll want to know what the variable is too. Okay, Tcl lists. A list is basically just an ordered collection of strings. Okay, they can be created several different ways. In this example, we're creating it using quotation marks, so we're setting the variable var equal to a list 1, 2, 3 ABC. We can use the puts command to print that, and we can see that it returns that list. We can also create nested lists, which is a great way to create some more complex data structures. You can see we're setting the variable var to a list, and that list contains 2 lists. It contains a list of 1, 2, 3, and then another list ABC. Now, Tcl list index start at 0, so I can use a command, a Tcl command called lindex of 0 for this variable. And if I do that, it will return me this first list. An lindex of 1 will actually return this second list. Okay. So you can build up these nested lists to contain more data. And if you want to flatten a list, you can use the join command to do so. Arrays are pretty nice for more complex data structures, or we like to use them if we're holding parameters, like user-defined parameters, for instance. So you create an array by using set, and then array name, you give it a key, and then the value. And you use the key to extract the value. That's all it is. They're basically special types of variables, and I'm going to talk about that in a minute. They use string-valued keys to access the variables, which I mentioned, and those keys are strings, so they can really be anything, including stuff like this, like I, j. So you can kind of fake these multi-dimensional arrays because, again, the key is just a string, so I could use 1, 1, 1, 0, and just effectively fake a multi-dimensional array. Now, one thing I will mention about arrays is they're nice for holding parameters. So if you're expecting a bunch of parameters at the beginning of your script, you can create an array called params, or parameters. The keys could be the names of the parameters and then contain the value that the user specifies. And then the nice thing is you can actually globalize that array and pass it throughout your entire script. It's small, it's cheap, it's okay, you can do that. The reason you would probably do that is because arrays cannot be passed in and out of procedures, again, which we'll talk about in a minute. A procedure is basically a function to do something specific that takes arguments, but you can't pass arrays in and out of a procedure because they're not real lists. Okay? The only way to do it is either to make it global and access it from the procedure, or bring it into the appropriate scope using the upvar command. Something that's not in your notes, which you may want to jot down, is a dictionary. So I haven't used a dictionary before, but I've been told that dictionaries solve a lot of the problems that arrays present, and that there's still this key value mentality and usage, but they are proper lists, and you can pass them in and out of procedures without having to globalize them or bring them into the proper scope. So you might want to look into using dictionaries for some of your more complex data structures. Again, I've heard they're fantastic for passing in and out of procedures. The expression command is how you're going to evaluate mathematical expressions. Okay, this is another Tcl command. You're going to use the brackets to kind of brace it, and then the curly braces to brace your expression. So for example, if we want to find the square root, we can use expression followed by curly braces and then our mathematical expression, which we want to evaluate. The braced expressions evaluate faster, and that's because there's no conversion to an expression required. And so that's typically how you're going to see a mathematical expression written in Tcl or in Glyph. There's also, I should mention, there's also some vector utilities available in Glyph in the PWU : vector 2 and vector 3 types. So you'll see some vector operations that you can perform from within Glyph. A Tcl proc, you can see how you create a proc. A proc is basically like a function. It's something that you're going to call repetitively. So for example, I would create a proc to create connectors, and the arguments I might look for would be the begin point, the end point, and then the number of points, the dimension of the connector. And that proc would basically return a connector. And so when you create a proc, you give it a name, you give it the arguments, and then the body of the procedure itself. When we name a procedure, again, it's a string. I like to use camel case, and I like to capitalize the first letter, and that's how I can differentiate between a proc and a variable in my scripts. Okay. As it mentions, the name is case sensitive. And args is the parameter list for the procedure. Again, like the connector example, our arguments would be the begin point, the end point, and then the dimension. Okay. So this is really important because procedures are going to be good for debugging purposes. If you're creating a connector 4 times, you don't want to have 4 duplications of the code, right? You only want to have it once so that if there's a problem, you can go right to that procedure and identify what the problem is and then have it propagate. For larger scripts, it's very important to do error checking. Not to mention, it hasn't been mentioned up to this point, comment your code, not only for you when you look at it a year down the line, but for anybody else who's going to use your script. Okay. The catch command is a great way to do some basic error checking. Basically, the way it works is you do catch, followed by the script that you want to evaluate, and then the result variable. That's going to contain either the result of that script or the error message. So the idea is that this command will not abort your script like it would if it encountered an error normally, where the script would just die. This is a more graceful way to abort your script and let your user know that there's a problem. So it's going to call the interpreter recursively to execute the script that you provide, and it's always going to return without an error. Now, if the script returns with an error, this error code, Tcl error, the value that's stored in that result var that you give it is actually going to be the error message, and you can return that to the user so they know what the problem is. If there is no error, the value stored in that result variable will be the result of the script. Okay. So that's basically how it works. You encapsulate the script that you want to see if there's an error, and if there is an error, it will return that message, and if not, it will return what you would expect it to return. Okay? Okay, now I'm going to talk about 2 things that are going to allow you to improve the efficiency of your scripts. So collections and modes are significantly going to improve the efficiency of your script for a number of reasons. One of which is if you use a collection, it's going to allow you to operate on several types or several entities at once. One type of entity, but operate on all at once. There's actually a command in Tcl. It's a for each loop. So if you give it a list, say, of 4 connectors, say we've got an unstructured domain bounded by 4 connectors, and we want to change the dimension of all 4 connectors. In the GUI, if we do that one at a time, what happens? Who can tell me what happens to that domain? Anybody? Unstructured domain. If you change the dimension of each connector, it's going to reinitialize the domain 4 times. Okay? For a small domain, that may not be a problem, but imagine a big domain or a lot of domains, something like that. Or maybe you want to do this one domain 10,000 times. Okay? It's going to be very time intensive. And there's actually a for each loop in Tcl that allows you to do something like that. You can get a list of 4 connectors, use the for each loop, march through that list, and apply the new dimension update. And every time you do, the domain's going to update, okay? Which is time consuming. Instead of doing that, you can use a collection. Okay? So no more for each loops. Use collections if you've got the same type of entity. And the way it works is you create a collection. So you can see we're using the pw : collection create command to create a collection. We're giving it a list using the set command. And then we're telling it for every entity in that list, set the dimension. Okay? So in our example, now what happens is we have 4 connectors. We're applying the dimension update. Okay? And when we call collection delete, which actually doesn't delete the entities, it just deletes the collection, okay? It applies that update. So now instead of our domain changing 4 times, it only changes once. Okay? So we've just improved the speed of our script by 4 times because now we only have to do that update once. Okay? Imagine for something much more complex, that can be a significant time improvement. Right? So that's how a collection is used. Highly encourage you to use collections, especially if you're using for each loops now. You'll probably realize the speed up by doing that. The other way that you can improve the efficiency is by using a mode. Okay? A mode is kind of a special state that you bring entities into. It's kind of like a sandbox. It operates on a copy of those entities. It doesn't do duplication checking or updates or anything like that until the mode is ended using the mode end command. Okay? When you use that command, that's when everything is applied. That's when duplication checking is performed and updates or entities are updated. So kind of similar to a collection and how that works. So you call pw : application begin mode, and there are different mode types. There's modification modes, there's copy and paster modes and things like that. You bring these entities into a mode, you perform the actions, and then when you're done, you call mode end. You'll also notice, actually, I'll mention that Pointwise, if you journal, you'll see modes and collections being used in Glyph as you're journaling. So that's a good indication that it does improve the efficiency. Some general Glyph scripting tips. Consistency. Obviously, if you write your scripts in a consistent manner, not only will it be easier for you to interpret what's going on, but it'll be easier for your colleagues to interpret what's going on. A lot of our scripts on the Script Exchange are very consistent. So if you read one, the other should look very similar. And that can help, especially when you're just getting started with Glyph scripting, learning the commands. Avoid hard-coded file paths. If I receive a script and it says, Bob's favorite directory, and I don't have that on my computer, the script's going to fail. So instead, use this command, set cwd file dir name info script. That basically says that everything happens within the directory where that script exists. So all the I/O and stuff happens in there. You write a PW file, you can write it right to cwd, and that'll be the current working directory of your script. Okay? Comments, very helpful. We already talked about that. Comments are actually preceded by a hashtag or the number sign, pound sign, whatever you want to call it. That's how you write a comment, and it's great if you write a comment, especially at the beginning of all your procedures, to document what that procedure does, but also throughout the procedure if it's longer to document what each step is doing. We already talked about journaling, and the big thing here is please use it as a guide. Please do not use it to write a script for you from scratch. Again, you'll probably write something more efficient than what it's going to dump out, and you'll have your own variable names. It'll be easier for you to read. And lastly, we did want to mention this, is the get by name function. the getByName function is okay to use if you've explicitly named the objects in your Pointwise file or in your geometry, for example. Basically, the way it works is it says if I need con-a, okay, you can use getByName to get that connector and then use it. And that's okay if I've named it con-a. But if I'm just using the named entities from Pointwise, it's probably not a good idea to use getByName because in the future we may change those entity names, right? And your script will break, okay? So if that's the case, you may need to implement some more logic to identify the entities that you actually need to use. Okay, so I know we're running out of time, but I will try to get through most of this example so that way it's in your notes. The code's actually in your notes, but I wanted to walk through it a little bit and then maybe show you what it does. Okay, so I have a tank, and in that tank there are 4 baffles. And this was actually written for a client who wanted to see how this might be done. And what they wanted to do was they have this tank, they know the names of the domains of the tank, and they know how many baffles they have. It could change, but what they wanted to study was the effect of the rotation of the baffles on the solution. And they wanted to be able to just feed this thing multiple angles and have it regenerate the mesh, all right? One of the ways that we found that you could do that is if you know the names of the tank domains and you ask the user to pick the baffle domains, the intersection of the two, basically the connector that's shared between those domains, would become your rotation axis, and then you could ask the user for some angles and you could rotate each baffle about that axis, okay? And that's basically how the script works. So the script is set up to take 4 domains, the number of baffles that we have. So it's running through, I think, 4 or 5 angles right now. And I'll show you what it prints out. Okay. So for each angle, it prints out the block number, because we could have multiple blocks in the tank. In this case, we only have 1. It prints out some diagnostic information like the maximum included angle, and I've set a limit in the script, and it tells me how many cells violate that limit. In this case, I see 0 cells in all of the cases I ran violate that limit, and it also wrote out all the PW files. So I could open up any of these and see the final mesh of the rotated domains and the initialized tank volume. Okay, so that's basically how the script works. So why don't we walk through it, and I'll show you some of the things that we did. So the first thing is we get the PW file name, we get the names of the tank domains, okay, and the angles that the user wants to rotate by. These are the user-defined parameters. We could have easily created a GUI and asked for these parameters in the GUI, but sometimes it's nice to run it in batch mode if you want, and this gives the user the opportunity to do so. Now, something that you're going to have in every single one of your scripts is this package require PWI glyph. That actually loads the glyph environment. All the commands and everything that you'll be able to use from glyph and you'll need to use that command to do so. You'll notice I'm using setcwd, which is the command I told you, so all the I/O happens within that same directory. So I could take that script, put it in any directory, run it, all the files will get written and read from within that location. And then file root, I'm just getting the root name of that PW file, because again, I'm going to create a bunch of PW files and just append it with the angle name, and then I'm just doing some timing using the pwu::time utility. So we've written a bunch of procs, and I'm just going to quickly, since we're running out of time, I'm going to quickly go through these procs, but they're in your notes so you can see them. These procedures allow me to keep the main part of my script really short and make it easier to debug and for people to tell kind of what's going on. So the first proc is get selected domains. So you notice that when I ran the script, the first thing I did is I picked all my baffle domains. Then I ran the script. This procedure basically returns those domains that the user had picked. So it's going through and it's creating a selection mask, much like you would pick the domain mask in Pointwise. I'm saying set mask, and I'm using the pw::display type to do so. I'm then saying, you know, if there are no domains, it'll return this message and then exit the script. So some very, very basic error checking. And then the last thing is, when I use that command, display get selected entities, to return the selected entities, it actually does so in an array. and the key into the array is domains. And what I need to do, so to return that from the proc, I don't want to globalize it. I'm just going to convert it to a list, and then I can return the list. Okay? So that's another way that you can use an array in your script to pass things in and out of procedures, is if you just convert it to a list, you can then pass stuff out if you don't want to bring it into the appropriate scope or globalize that array. The other procedure I have is get cons from DOMs, and it expects an argument domains, and this is basically going to return the connectors from the domains, because I need those to figure out what connectors are shared by the tank and the baffles so I can get my rotation axis. So I loop through each domain, I get the edge count, and then I loop through each edge, I get the connector count, and then once I get my connector count, I loop through and I store all of the connectors to a list, and I return that list for the domain. Again, it's very much like the thing you would do in Pointwise itself. I mentioned only use get entities by name in some specific instances. This is one of them. I know the tank domains, so I have a little proc that only does one thing, and it just uses the pw : entity get by name function. That's all it does. Okay, this procedure gets the shared connector. So I give it a domain, and then I give it a group of domains. So I give it like my baffle domain, one of my baffle domains, and then I give it the tank domains, and what it returns is the shared connector. Okay, and that shared connector would again become my rotation axis, which is what this proc does is, you'll notice I'm creating an array called curve. You'll notice that I've also globalized that array so I can pass it in and out, because there's a lot of information that I need. I pass in my connector, and ultimately what I get out of this is an array that contains my rotation axis. So that's all that proc does. I'm globalizing curve here so I can access that array from within the rotational transform procedure. This procedure takes the entities that I want to rotate and the angle with which I would rotate them by, and then I create a transformation mode. So I'm actually starting a mode, I'm working on copies of that entity, and then I'm transforming it. And this pw : transform rotation anchor, that whole part is what gives me my rotation matrix for the transform function. And then at the end, I end the mode, and it's actually transformed the entities. Another proc is to initialize the blocks. Remember, I mentioned I don't know how many blocks there are, but I do know that when I rotate the domains, I'm going to need to reinitialize my unstructured volumes. Okay? When you modify a domain that's part of an unstructured block, those of you who've done that know it blows away the block. It empties the block, so you need to reinitialize it, and that's what this domain does, or what this procedure does. A simple procedure to save the project. So I give it the name, the angle, and the directory where I want to save the project. A procedure to examine the blocks. So I bring the blocks in here, I create an examine object, I add the entity, I set some limits. So my upper limit was 170 degrees, I examine it, and then I can print some information using the putS statement. And this is the command I was using, block examine get above range, and this will tell me how many cells are above the upper limit that I specified. And this is the main part of the script. So you'll notice, this is pretty simple, but I had a lot of procedures. And the reason I had a lot of procedures is because I could keep the main part of my script very, very simple and straightforward. So I'm just calling all of those procedures from the beginning. I get my domain list by calling get selected domains. That returns all the baffle domains. I get my tank domains. For each angle I loop through, I get the curve axis. I perform the rotation. At the end, I get all of my blocks. I initialize them, and then I save the project, and then examine and print all that to the message window. And at the end, I print the elapsed time. So that's basically how that works.